All right, so let's talk about absolute value. To start off with, what does absolute value mean? What does it mean sort of in terms of a concept? Well, what it really means is a distance from zero. Mechanically though, what does that mean? You know, we can think about it as a distance, but what we really mean is that whatever's inside those absolute value symbols just becomes positive. That means if we have a negative number in between those absolute values, that will become positive. And anything that's already positive, well, that just stays the way it is, which is very simple. Again, the absolute value of 5 will simply be 5. Again, that makes sense because if you think, well, how far is 5 away from 0? 5 units. Well, what about -5? If we talk about the absolute value of -5, well, it's the same thing. It's 5 units away from 0, just the other direction. So what that means is absolute value will also act as parentheses. So we work inside the absolute values and then worry about taking the absolute value of whatever the result is. So taking a look at this example, we have the absolute value of 10 minus 8 minus the absolute value of 5 minus 11. So again, let's start inside the absolute values first. 10 minus 8. Well, nothing tricky there, that's just 2. 5 minus 11, again, nothing too tricky there, it's just -6. Now, we can take the absolute values. Absolute value of 2, that's already positive, so it stays as positive 2. The absolute value of -6, well now it's a negative, we make it positive, that turns into just 2 minus 6. 2 minus 6 then is -4, and we're done. Not too bad. So that's again pretty straightforward, work from the inside out, and then take the absolute values. Now what happens if we have an actual equation involving absolute values? Now what do we do? Well, we have to deal a little bit differently now because inside the absolute values we can't do anything yet. For example, if the absolute value of n minus 12 equals 7, then what is one possible value for n? Well, again, here we don't really have anything happening inside the absolute values yet. I don't know what n is, so I can't do n minus 12. I'm looking to solve for n. But in order to get that, we have to remember what's inside those absolute values may be positive or negative. So really, in this case, we end up with two separate equations. So we could have n minus 12 equal to positive 7, or we could have n minus 12 equal to negative 7. So we write down both of those equations and then we solve them like we would normally solve an equation. Add 12 to both sides, that will give us our two solutions. So we'll end up with n equals 19 and n equals positive 5. Again, we can think about this absolute value as a distance from 0. So we looked at how to solve this in a really purely algebraic way. Well, we can also kind of think in terms of a picture. So in terms of a picture, again, I'm going to think about this as a distance from a value. Now, if we have the absolute value of a regular number, we think about that as a distance from 0. Now, if we have the absolute value of a difference, that will be seen as the distance between those two values. So let's go back to that same example we looked at before. We said if the absolute value of n minus 12 equals 7, then what is one possible value for n? Well, now instead of thinking about this as, hey, let's write two equations, I can draw a picture. Well, if we look at the absolute value of n minus 12, the way we think about that is that the distance between this unknown value n and the value 12 is going to be 7. So on a number line, we could put 12 right in the middle, and I think, well, the distance between n and 12 is 7. So if I go 7 to the left, I'd be at n. If I go 7 to the right, I'd also be at n. And that makes it a little bit easier to think about sort of from a visual standpoint. Well, if I go 7 to the left of 12, we'll end up at 5. If I go 7 to the right of 12, we'll end up at 19. So we end up with the same two solutions, n equals 19 or n equals positive 5. Now when we add in an inequality, this will add in a little bit extra complexity, simply because inequalities, well, they have their own rules. So taking a look at another example, if the absolute value of 2x minus 5 is greater than 9, what is the solution set for x? Now notice here, first of all, we have a little bit different wording for our question. Instead of simply what values are our solutions, we have a solution set. This is natural, we have an inequality, so we'll have a whole range of values that will work as a solution, not two specific points. Now we start out again the same sort of way we think about having an equation. this inequality will lead to two separate inequalities. One will be simply writing it down without the absolute value symbols. 2x minus 5 is greater than 9. On the other hand, remember, the inside between those absolute values could be positive or negative. So we have to account for the negative as well. So that will give us another inequality. Negative quantity of 2x minus 5 is greater than 9. Now, when we are actually solving these, on the left-hand side, we have that inequality with a negative sign. Well, we can deal with that negative sign first. On the right, we have our standard inequality. We can solve that the way we normally would. On the left, we'll just negate both sides, but remember, we're negating an inequality, which means when we do that, we have to flip the sign of that inequality. The greater than becomes a less than. And at that point, we can solve them as we know how. That will give us, our two solution sets. We have either x is greater than 7 or x is less than -2.